composition of two functions is when you basically have one function inside of the other. So you're performing the operation of your inner function first, taking whatever result you get, and then plugging it into your outside function. So it's kind of like do one thing, take your result, do another thing to it. So if we do one here, I'm going to start with E. I'd like to rewrite it with my other notation. So we're performing f of 2 first, it's our inner function, and then taking our result and plugging it into g of x. So I'm going to f of x and plugging 2 in for my variable. That's going to give me 0. And then if I take that result that I got from doing f of 2 and now plug it into my outside function, which is g, if I plug 0 into 2x plus 6, I'll have 2 times 0 plus 6, which is just going to get me 6. So our end result, g of f of 2, is equal to 6. Let's do one where you don't have a value to plug in for your variable. I'm still going to rewrite it. So this is f of g of x. Order is important, so make sure your inner function is your second one. Well, g of x is just 2x plus 6, with x as itself, not replaced with any number. So I'm going to take that whole 2x plus 6 group and plug it into f of x. So make sure to put it in its own set of parentheses. You're going to have 2x plus 6 quantity squared minus 4. And then we're going to need to actually do that. So if we square 2x plus 6, spread it out and take it times itself, and then subtract 4 from it, that's going to be what f of 2x plus 6 and f of g of x is. So I'll have 4x squared plus 12x plus 12x plus 36 minus 4. So my final result when I combine like terms is 4x squared plus 24x plus 32. So this time we're not plugging numbers in for our function values, we're just taking and plugging one function into another. So the little notation with the open circle I'm not a huge fan of, so I'm going to rewrite this as f of g of x with my parentheses. And then I'm taking my function g of x and plugging it into my outside function f of x. So if I plug 4x plus 5 into 6x to the negative second in place of my variable, it's going to look like that. And then simplifying, the 4x plus 5 is to the negative second, so I'll make it in my denominator squared, and then I'll go ahead and square it, so multiply it out times itself, and I'll end up with 6 over 16x squared plus, let's see, that'd be a 20x and a 20x in the middle, and then plus 25. So when you're all said and done, you'll have 40x in the middle there, and that's your result. Why don't you guys try the second one? All right, let's see how it went. So g of f of x means I'm going to be taking my functions f of x and plugging it into g of x. So in g of x, I'll be replacing my variable with 6x to the negative second. So I'll have 4 times my 6x to the negative second plus 5. And then if you multiply those together, that's going to give you 4 times 6 is 24, x to the negative second plus 5. And then I don't want to leave negative exponents in it, so I'll go ahead and make it 24 over x squared plus 5. Remember, only the x is being raised to the negative second, not the 24. I could get a common denominator and write this as a single fraction, so I could multiply times x squared over x squared and then get 24 plus 5x squared all over x squared if I wanted to. So either one of those is acceptable. Okay, so some more composition of functions. This time it's going to get a little bit messy. So we're doing f of g of x, where g of x is that whole entire fraction. So I'm going to take that 2 of x plus 7 all over 4, and I'm going to plug that into f of x where my variable x is. So I'm going to take my variable and replace it with that expression, which is going to mean that my function's going to look like 2x plus 7 over 4 to the negative first power. Which, if you think about a negative exponent, what it's going to do is it makes the top go to the bottom go to the top. If you think about the whole thing being to the negative first, you could rewrite it as like the top to the negative first and the bottom to the negative first. And then your negative exponent makes it like 1 over that. So it essentially ends up flipping it, and you end up with that result. Now g of x is kind of like a weird little, oh my goodness, it's nested inside of itself type thing. So you're going to take g of x, that fraction, and you're going to plug it back into itself, basically. So you're going to take 2 of x plus 7 over 4, and in that same fraction, replace your variable with 2x plus 7 over 4. So it is going to look a bit crazy. Let me write my original function g of x first. So this is just 2x plus 7 over 4, plain old g of x. And now I'm going to take and replace my variable with 2x plus 7 over 4. So I kind of had to squeeze it in there, but now I need to simplify. That's going to be like 2 over 1 times 2x plus 7 over 4. So let me write it a little more obviously. And then I'll multiply my 2 to my 2x plus 7 to get 4x plus 14 over 4, plus my separate 7 that's not part of its fraction. Now I need to go ahead and can't leave fractions within fractions. What a mess. So let's get a common denominator on top so that I can add my 7 to my 4x plus 14 over 4. So if I multiply 7 by 4 over 4, I get 28 over 4. And whole thing's still over 4, but that's just kind of like chilling down there. And now I can add my fractions on top together and get 4x plus 42 over 4 all over my 4 from my denominator. Okay, we're getting closer to having it simplified. So I'm dividing these two fractions, which means I can just take my fraction on top, leave it be, and then multiply it by the reciprocal of the denominator. So I'll multiply it by 1 over 4. And I'm going to get 4x plus 42 over 16. Are we done, you ask? Not quite, because 4x, 42, and 16 all have a common factor of 2. So let's reduce our fraction, divide out a common factor of 2, and you get 2x plus 21 all over 8. There you go.